Hi guys, welcome to your next set of notes. Hopefully by now you know the drill, but if not, please make sure you have something to write with and something to write on because you are expected to take notes on this as always. Remember, these notes will be an absolute amazing resource for you when you're working on classwork, when you're working on homework, when you're working on assessments, all of that. So please make sure you're following along and you have these notes to reference. All right, so let's get started. Today we are talking about sections 10.1, stem and leaf plot, and section 10.2, histograms. Our essential question for today is, how can you use place values to represent data graphically? And both of these sections are both explaining how to represent data graphically in two different ways, which is through stem and leaf plots and histograms. So first we are going to begin with stem and leaf plots. And let's talk about what a stem and leaf plot is. So a stem and leaf plot is a visual representation of data, and remember I abbreviate a little bit, a visual representation of data that uses digits of data values, to organize a data set. And remember, this is one of our measures of variation. So I'm also going to put that this shows variation because it shows variation in a data set. Okay? So a visual representation of data that uses digits to organize values of a data set. And we're going to show you one of those here in just a second, and we're going to use this data set over here to the left in order to make that. Okay, so I have the steps here listed for you, but please make sure you write them down because they're going to be important for you when you are making ones of your own. All right, so step one is going to be ordering the data. Remember, we're using this data set over here to the left, so let's go ahead and put in order. I'm going to cross these off as I go to make sure that I don't skip a value, because that will be a simple mistake that it's easy to make and that will throw off our stem and leaf plot. After that, it looks like 14. Oop, I skipped 12 two times. 12, 12, 14, 15, 17, 18, and it looks like 21 and 24. And it's always a great idea to count up the data set, make sure you have the same amount of values on each so we can make sure that we didn't make a silly mistake and skip a value. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over here I have 3, 6, 9, 12. So we're all good. Let's move on. So the next step is to choose the stem and leaves. So you don't even know what stem and leaves are yet, and they're going to represent the different place values of numbers. So what I'm going to put as a little note here is take into account the place value in your set. So we're going to have to take into account the place values of the individual set we're talking about in this case. In this case, our set ranges from 0 to 24. So it would be a good idea for us to use the tens place as our stem. So we're going to write the stems on the left of a vertical line, and the leaves are going to be to the right. So what I'm going to do over here is I'm going to write stem, and then I'm going to make a line, and then I'm going to write leaf. Okay, and over here, since I said the data range from 0 to 24, I said a good stem to use there would be the tens place. So I'm going to put a 0, a 1, and a 2 to represent the tens place there. Something that's really important here is, just like I had mentioned to you guys when we worked on dot plots and when we worked on box and whisker plots, you cannot skip, you have to scale evenly. So for example, I have to go in order. Even if there weren't any tens values, for example, if there was just like 2, 6, 20, and 21, but not anything in the tens, I still have to show that one because you have to scale evenly. And that will let us show if there's any gaps in our data also. So have to scale evenly, even if there's no values. Even if no values. Okay, so all we're gonna do, and we're gonna make a key over here to the side that tells us, explains to us what our data looks like. So for example, if it was 0 and 1 over there, we're gonna give one example. So 1 with the line and 4 is gonna equal 14. So we're just gonna place all of our values with a 0 in the tens place. So 0, and we look at the values above that we ordered. In this case, you don't put commas or anything, you just space it. So 0, 2, 6, and 8. Our next value is 12, so that has a 1 in the tens place, so we're going to move on to that 1, and we're going to go 2. And in this case, 2 12s occur. We have to put that 2 twice, just like any other data. You would have to, in a dot plot, you'd have to represent it twice. Same thing. 4 for 14, just like our example key. 5, 7, and 8. And then we're going to go to 20s, and we have 21 and 24. And that's it. That's how to do a stem and leaf plot. It's literally that simple. This is our stem and leaf. I'm going to just put a box around it so you know what is that. And then we're always going to have a key, just like we made over here, which gives our audience or whoever's looking at it the example of what place value that represents. Okay? So let's try to analyze some data now. All right, when we are looking at this stem and leaf plot over here that says plant heights, we are going to answer the following questions over here. We're going to find which statement is not true based on that data set. Okay? So I'm just going to go through them and mark off with an X if I think that, or a check mark if it is true, or X if I think it's not true. Okay? So this says most of the plants are less than 20 inches tall. So let's take a look over here, and we see that, remember, this 2 would represent 20, and it's saying most are less than 20 inches tall, so most would be represented over here. When we're looking at that, that definitely looks true, because look how many values are in there. If we wanted to, we can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 12 out of 15 are less than 20. So I think that's definitely true. We're going to give that a check because that's true. Most of the plants are less than 20 inches tall. Okay? The next one says the median plant height is 11 inches. All right. The median plant height is 11 inches. Since the median is going to cause us to do a little bit more work, I'm going to skip that one for now and move on to next, see if I can determine if it's true or not true. The next one says the range of the plant heights is 35. So remember, for range, we would take our max, our highest value, and our minimum, our lowest value. So when I look over here, I'm going to highlight this time. In pink, it looks like 36 was our max value and 1 was our min. And then we would do 36 minus 1, which equals 35. So that's true. The range is 35. Perfect. So let's move on to the next one. The plant height that occurs most often is 11 inches. So remember, most often is our mode. So in this case, if we see it occur more than its peers, then it would be most often. So I'm going to get a different color highlighter this time, and let's look. In that first row, all of those numbers just occur once. In that second row, I see 1 and 2 ones. In that third row, I just see 1, 2, 1, 5. And in that fourth row, I just see 1, 6. So that's right. It looks like 11 is the only value that occurs 2 times. So it definitely is the mode. So that is true as well. So this tells us that by default, B would probably be the statement that's not true. But let's actually make sure it is so we can be confident. So in this case, when we count up, I already counted it from that first question, there are 15 values. So that means if there's 15 values, if we did 15 divided by 2, that would give us 7.5. And remember, we round up. That means our 8th value would be our median. So we can just count to 8. And you can see when we count to 8 over here, the value we actually end up with is going to be 1, 2, 3, 4, 5, 6, 7, 8. This 0 right here which would tell us that our median would actually be 10. And this says it's 11, which is not true. So B is actually the one that is not true. The median plant height is not 11 inches. Okay, so that's how we use a stem and leaf plot to analyze data. All right, so let's go ahead and move on to our next topic, which is histograms. And so let's first begin with talking about what a histogram is. So what is a histogram? So a histogram is a bar graph that shows the frequency of data values in intervals. That shows the frequency, how frequent something occurs, of data values and the difference about this is it's in intervals of the same size. So when we're talking about intervals, that's a section of data. So for example, instead of saying 1 occurs once, 2 occurs twice, 3 occurs 3 times, we would say 1 through 5 occurs this many times, or 1 through 3, or whatever our example was. Okay, so we are going to practice making a histogram with this data set to the left right now. Okay, so take a look at this data set over here to the left. It already gives us intervals of data, so we are just going to create that in a bar graph. So the first thing we have to do with that is label the axes. So we are going to have our vertical line, which is called an x-axis usually, and a horizontal line, which is the y-axis. So let's go ahead and do that. So I am going to do this by frequency. It looks like our frequency goes from 0 to 11. So our range is going to have to be over here to the side. I'll probably go by 2s. So I'm going to make this 2, 4, 6, 8, 10, 12. And then I am going to label that frequency just as it does. We have to draw and label. And then over here, I'm going to place my intervals. So this is going to be 1 to 3. This one is going to be 4 to 6, 7 to 9, 10 to 12, and 13 to 15. And that is going to be labeled number of laps. Number of laps. Okay, so we drew and labeled the axes, and now all we do is we draw a bar to represent each frequency. All right, so let's do that. I'm going to do it in a different color. So 1 through 3 occurred 11 times. It's going to be in between 10 and 12. And then, of course, you can shade it in or not. I'm just going to shade it in a little bit. And the thing about histograms is the bars always touch each other. Since they're representing intervals, we go straight from 3 to 4. There's no space. They're always touching each other, okay? So 4 to 6 occurs 4 times. It's going to be right here. And once again, you can choose to fill it in or not. Sometimes you'll see them in different colors. 7 to 9 occurs 0 times. So that's the one time it's going to look like they're not touching each other, because since it occurs 0 times, it's going to be a gap in the data. This next one occurs 3 times. And our last one occurs 6 times. Okay. So that is it. That's how you draw a histogram. Remember, the bars are always touching since they represent intervals. Bars are always touching, and the only exception here is because there's a gap. So this is a gap in the data. But other than that, the bars should have been touching. Okay? So it's really simple. All we're doing is basically drawing a model of our data. So so we can understand it visually rather than just looking at the numbers. The graphs help us to visualize it in a different way. Now let's move on to analyzing these graphs. Okay, so we are going to take these two graphs and we're going to see which statement cannot be made using the data displays above. So once again, we're analyzing graphs, analyzing visual representations of data. So let's get started. This first one says 12% of the class completed less than 10 push-ups. So over here, we see the pie chart, and that would tell us the percentages of push-ups that students were able to complete. So over here, so this question says 12% of class completed less than 10. So less than 10 would be referencing 0 to 9, and it said 12% of class completed that. When we look at that part of the pie chart, we see that it does say 12% as displayed right there. So that would be true. So that statement can be made. So that one's true. We will move on. 5 students completed at least 10 and at most 19 push-ups. So I think it would be a good idea for that one to look over here at our histogram. So 5 students completed at least 10 and at most 19 push-ups. So here, at most 19. So here we would need to see if 5 students at least completed this much right here. And when we look, that's in between 4 and 6, and that would mean 5. So 5 students completed at least 10, so 10 to 19, and at most 19. And that's correct. 5 students did complete that. So let's move on. At least 1 student completed more than 39 push-ups. So when we're looking over here, this is 40 to 49, and it does look like at least 1 student completed that. So that looks true as well. So we would think by default that this D1 was going to be the one that is false, but let's just make sure. 29% of the class completed 30 or more push-ups. So let's see, when we look at this pie chart again over here, this shows us 30 to 39. So it says 29% of the class. When we look over here, it shows 24. So that would be false. That one is the one that's incorrect. So we would highlight, oops, I did not mean to do that. So I would highlight D as the incorrect one. That's a statement we cannot make because 24% of the class did that. Okay? And that is it. Hopefully you guys feel pretty confident in these new visual representations of data. Remember, we're going to practice a lot more in class, so make sure to ask any questions if you have them, and we will see you next session.